Is time real, or is it just an illusion created by perception? Do past, present, and future exist all at once? In this video, we're going to explore this mind-bending question through the lens of three powerful disciplines: quantum physics, neuroscience, and life sciences. Each offers a different angle, and together they might reshape your view of time itself. Imagine a world where time isn't as real as you've been led to believe. Consider the idea that the past isn't behind you, the future isn't ahead, and the present is merely a lens. We will delve into the illusion of time and reveal how quantum biology helps explain our experience of its flow. Time is a human experience, not a universal truth. Let's start by examining our traditional understanding of time. We learn to view time as a straight pathway, past leading to present, then flowing into future. Yet, this perception is shaped by our biology and senses. In the cosmos, time behaves differently. According to Einstein's theory of relativity, time isn't absolute. It bends, slows, and stretches under various conditions. Einstein famously remarked, "The distinction between past, present, and future is only a stubbornly persistent illusion." This statement laid the groundwork for the block universe theory, where all moments exist in tandem. Each moment is like a page in a book, already inscribed. You aren't traversing time, you're simply becoming aware of one page at a time. Let's now turn from physics to psychology and how the brain constructs the illusion of flow. Why does time seem to advance if every moment exists simultaneously? The answer resides within memory and consciousness. Our brain shapes our experience of time by storing and comparing events, creating the sensation of flow. Here's the twist. Neuroscience reveals our memories aren't perfect snapshots of the past. Studies suggest that as much as 60% of our recollections are distorted or reconstructed. The leading cognitive psychologists Elizabeth Loftus and Daniel Schacter explain, memory functions as a storytelling machine. Each act of remembering involves rebuilding, not retrieving. With every recall, we modify the memory based on our emotional and mental state. This means the past isn't a fixed event. It transforms into a story, altered every time you remember. And the future? That too is a simulation created by this same storytelling process. Now let's shift our focus to the body, specifically its internal timing mechanisms, intertwined with quantum phenomena. We are bringing in the body, biological timekeeping and quantum insights. You may already know about circadian rhythms, the body's internal clock dictating when to sleep, wake, or feel alert. This rhythm is governed by the suprachiasmatic nucleus, SCN, a tiny part of the brain responsive to light and dark. Yet this clock influences more than just your sleep schedule. It dictates neurotransmitter release in your brain. For example, melatonin induces sleepiness. Cortisol helps you awaken and focus. Acetylcholine governs rapid eye movement, REM sleep. Orexin maintains alertness and energy. These chemicals rise and fall in an exact rhythm throughout the day. But here's the enigma. How does the body maintain such precise timing, even amidst environmental changes? This is where quantum biology may shed light on the matter. Inside your cells, enzymes facilitate essential chemical reactions, from digestion to brain activity. Some reactions occur more rapidly than classical science predicts, maintaining stability across various temperatures. This phenomenon could arise from quantum tunneling, where tiny particles slip through barriers they shouldn't. Imagine bypassing traffic instead of idling in it. That's akin to tunneling. This could illuminate how your body keeps its chemical timing smooth. This quantum precision might underpin your biological clocks, even when conditions are less than ideal, like jet lag or stress. Erwin Schrödinger observed that living systems resist the pull toward chaos, unlike most of the universe's makeup. In a sense, life bends decay rules, staying organized potentially through quantum shortcuts. An alternate idea posits that different body parts stay synchronized using small bursts of light, known as biophotons. Researchers believe these light signals may communicate time-sensitive info across various organs, linking your brain, gut, heart, and immune system. What does this mean for human experience? It implies that your feelings about time, energy, mood, and even mental well-being may be shaped by subtle quantum processes. When your internal clock malfunctions due to sleep deprivation or chronic stress, it's more than an inconvenience. It could disrupt your brain chemistry, affecting mood regulation, decision-making, and how fast or slow time seems. This invites us to see time not merely as a ticking clock, but as something intricately woven into your biology, influenced by both external factors and internal quantum effects. Zooming out again, theoretical physics and the origins of time. As biology explores how we track time, physics questions a fundamental aspect. Does time even exist? In 1983, physicists Don Page and William Wooters proposed a captivating concept. Time might exist solely for those entangled with systems resembling clocks. From an external viewpoint, the universe could seem static, a timeless freeze. This theory suggests that time doesn't exist independently. It arises from interactions among systems. It's not a pathway we traverse. It's a byproduct of relationships. The role of consciousness and the limits of speculation. Some theorists propose that consciousness itself generates time, or even reality. This notion often connects to the observer effect in quantum physics, where a particle's behavior alters upon measurement. However, it's essential to clarify. In scientific terms, an observer involves anything that interacts with a system, like a sensor. Claims circulate about the brain functioning like a quantum computer, suggesting consciousness may derive from quantum effects. Yet many scientists maintain skepticism. Physicists Howard Wiseman and Jens Eisert argue that the brain is too warm and chaotic for fragile quantum states to persist. Max Tegmark went even further, revealing that any quantum coherence in the brain dissipates almost instantly, far too rapidly to influence consciousness. While the concept of quantum consciousness piques interest, solid scientific backing is still lacking. Let us turn now to comparing perspectives, life science versus quantum physics. And where does this leave us? From the life sciences viewpoint, time is something our bodies experience intimately. It intertwines with biological rhythms, brain chemistry, and our ability to remember and anticipate events. Yet in quantum physics, time may not exist at all, at least not as a basic reality. Instead, it could emerge from interactions among particles, systems, and observers. Physicist Julian Barber sums it up: change is real, time is not. Carlo Rovelli, in The Order of Time, emphasizes, the world is not a collection of things. It is a collection of events. Time is perspective, not a fundamental entity. In essence, biology helps us perceive time. Physics challenges us to question its existence. So, is time real? Here's what we understand. Your past is molded by memory, and memory is ever-changing. Your future is shaped through imagination, always in flux. Your present, the only moment you truly inhabit, may also be a constructed illusion. So is time tangible? Perhaps not as we've always perceived it. Time might be fluid, adaptable, and even deceptive. And this notion doesn't merely challenge our scientific understanding. It prompts a reevaluation of how we live our lives. So, if every version of you already exists, the joyful one, the healed version, the fulfilled soul, then the more pressing question is, which version of yourself are you currently tuning into? Let me know in the comments. Want to dive deeper into the thinkers behind these ideas? See the full list in the description. And if this resonated, don't forget to like, subscribe, and share to join the journey.